So now in this video we're going to talk about power and wattage. We're going to use this example circuit here. We're going to light an LED. We're not going to actually do this, just the drawing, but light an LED with a 9-volt power source, a 9-volt battery in this case, and we need to limit current. So the LED is going to drop about 2 volts, and the rest of the voltage we need to limit current with. And so we're going to use a resistor. That'll put 7 volts across it, and we'll get a little less than 15 milliamps, but close enough to 15 milliamps where it'll measure almost 15 milliamps. And so LEDs, typically the little indicator LEDs can handle about 20 milliamps. So that'll protect the LED. But we also have to protect the resistor from overheating. So we do that by picking a value that will protect it, which again limits the current. So now a power source like a battery provides voltage and current. Power is voltage times current in electronics. 1 volt times 1 amp is 1 watt when it comes to electronics. Most resistors are rated for a quarter watt or 0.25 watts, but you still want to keep them below half of that to make sure they don't overheat. So that's 0.125 watts that you want to stay below. In our example, we have a 470 ohm resistor. If you just pull that out of a random kit, it'll probably be a quarter watt resistor, unless you get a special resistors with a different wattage rating, generally higher. But in any case, we already did the math earlier. We got about 15 milliamps or 0.015 amps. We got to do the math in amps. And so 7 volts across the resistor times 0.015 amps, we got 0.105 watts, which is a little bit below the 0.125 watts that we are aiming for. Now, you may have noticed we've only been talking about wattage for the resistor in this circuit, not the LED or the multimeter set to measure current. And that's because low resistance components, they have a current rating. There's a certain amount of current where they will start getting too hot, and you don't really have to worry about the voltage though, because they don't really build up a voltage across them other than the LED, about 2 volts, but after that point it stays at about 2 volts. So the only difference being made in the wattage of the LED is how much current is flowing through it, because the voltage is pretty fixed. The multimeter tries not to interfere with the circuit at all. It's very low resistance. It just tries to measure the current, and so really voltage doesn't build up across it too much, but the circuitry still has, usually you set it to a setting with a maximum current, and so you just got to stay below that current. So now a battery is a power source. It provides voltage and current. It does not do so perfectly though. There's a little internal resistance, so it'll build up some heat, and there'll be a limit to the current that it can set. And so usually you use batteries for a lower current right there. The resistor we already saw is taking the energy, the voltage across it, the current through it, creating heat. With the LED, we got a certain amount of voltage, but for the most part, the current going through it, and thus the power, is providing light. But it does produce some heat, and so you do have to limit how much current you put through it so it doesn't get too hot. But by then the LED is brighter than you want anyways. So you can use lower current to produce light and not much heat. Now the meter, as we said before, it just lets current flow through it practically freely. It's just trying to measure it, not influence it at all. And so really there's no voltage built up across it. You'll probably, if you got a really sensitive meter, you might see a little bit of voltage, but it's almost 0 volts. And when it comes to power, if there's no voltage across a component, it's not creating any heat. There's no wattage. And same thing, if for some reason there's no current flowing through the component, if we remove the meter without making a connection there, no current's going through the resistor, no current's going through the LED, and so there is no power at that point. It's just potential energy, just voltage sitting there waiting to do something for the battery. So now the main takeaway is that understanding power and wattage is really important if you're going to design your own circuits. For example, we come over here to an older diagram from an earlier circuit where we also looked at the main circuit of this video, and we're going to protect an LED from 12 volts. So I already did the math. I got a value here. You can just grab that value and use it, and as long as I didn't make a mistake, you know that everything is safe. But we're going to verify the math really quick. So we got a 1000 ohm. We're going to look at why I chose that. Now we're only getting 10 milliamps. We got 12 volts minus 2 volts across the resistor, 10 volts, 1000 ohms, and so we got 0.01 amps flowing through there, 10 milliamps, which is lower than the current we got flowing through the 9 volt example. But the reason why, we already looked at the wattage of this resistor. It's 0.105 watts. The math's pretty easy here, so we got 0.01 amps times 10 volts, so times 10 will be 0.1. So it's practically the same wattage, 0.1 watts and 0.10 watts right there. But we got less current. That's because with the extra voltage, we got to dissipate more heat. The resistor is going to build up more heat if we pass the same amount of current. So we actually got to lower the current to get the same amount of heat generation. These are both going to be quarter watt resistors unless we grab a higher wattage resistor. Then we could get more current. But we're staying just a little bit below, in both of these cases, the recommended current of 0.125 watts. So that's why I ended up grabbing this value resistor and that value resistor when I designed these circuits. So wattage is really important for designing the circuit, but it's also important to understand just looking at circuits. Maybe I make a mistake somewhere, and you might pick that up if you do the wattage calculations or other people's circuits. So in any case, hopefully that made sense. This video is long enough. Hope you enjoyed. Make sure you check out one of the other videos I'm posting and check out the links below. Thanks. I'll see ya in the next video.